they doing the experiment, this is not existing. The speed of light still travel in here with speed of light in the reference, and travel in here again speed of light. Cannot larger than speed of light. So that's what they find out. Then the next thing they find out, due to the Maxwell equation development, the light is now understood to be the EM wave that requires no medium for its propagation. But it too can propagate in different medium with different speed. But if there's no medium, they still can do that. Okay. So now, after that is done, a lot of people study, and this is what makes the unique. So that is the things we try to encourage the students. Make assumption, do the prediction, and what if your assumption is wrong, no problem, start over again. That's why the physics training enable you to do something new. So they're making the platform and do something different. For example, after Einstein go into the lab, discuss with them, or doing some communication with them about this experiment, Einstein, very boldly, very bravely say, okay, I'm going to do the two postulates. These two postulates basically establish a special relativity principle. What is the two major assumptions? One is about the principle of relativity, or the law of physics are the same in all inertial reference frame. By the way, this is almost like the Newtonian mechanics system. Okay, this is the first one is related. No matter what happens in different inertial system, they are still, the law of physics we apply will be true. Yes?
What does that say for its?
Pardon?
What does it say? No medium for
No medium. That requires a no medium for its propagation.
Propagation.
It means what it means that light can travel in the vacuum. That's why the light of the sunlight can travel all the way, go through no medium to travel to the sun, travel to the earth. The second one is constancy of speed of light. No matter where or what reference frame is, the largest speed is speed of light. There's no such thing called 2c. In which cases, it says, in these cases, if the light travel here is speed of light, even this inertial frame travels speed of light, when this guy see it, the light still travels the same speed of light. So now, you have a modification. You have to learn Einstein to say, hey, how to avoid this contradiction, okay, and how to set up a kind of new correction factor. And the new correction factor later on is called gamma. Okay, gamma. So in these cases, we let it go into the section 9.4. In the section 9.4, we talk about the time. In this case, it's called time dilation. Based on this, in these cases, then one is called the light path. This is in the O pi, Y pi, X pi system. So the light shining through the guy sitting still and shining flash lamp go through the ceiling with the flash lamp shining there and back. So if you consider the speed of light, you see that time measurement turn out to be because it goes to d 2 times. So in this particular system, delta Tp is equal to 2d divided by c. 2d divided by c. That establishes the time required for a light travel here and return back. Now, consider, if you do that, just consider somebody throw the object like this. You will throw the object, and then this car is moving. So you consider photon is moving up and down, but outside the light box, you see the object travel like this. The photon travel like a triangle shape. And hitting this mirror and the triangle shape back. Okay, so that the hitting here and back. If that's the case, then this inertial system moving with the velocity v. And when this is moving, the time, the length we travel is a v times delta t. V times delta t, and this cases is equal to hypothesis equal to half the t. That means the time travel from here to here is equal to delta t. You travel half of it, that means equal to delta t divided by 2. So the distance-wise is a v times the delta t divided by 2. So if you're bisecting this, become another triangle. This particular right triangle, so obeying this way, the hypothesis equal to sum of the square of two lengths. So based on this, c half a c delta t square equal to half of vct square divided by 2 plus d square. So this is the situation with delta t. So using algebra, I'll go through the algebra. So you factor the delta t out, delta t square, in which case you get half a c square minus a half of v square equal to d square. You factor this out, and then you move this down to here, and then you divide by delta t. So when you do, go to one step, in which case is c square minus v square times 1/4, and then delta t square equal to d square. So in that case, you move this down, that's equal to 4. So c square minus v square times delta t square equal to 4d square. Then you square it on both sides, and then take another relationship. 2d is 2d divided by c equal to delta tp, so that you got this relationship. Delta t equal to delta tp divided by 1 minus v squared divided by c squared. We finally define this term. Usually they define this term is a reciprocal of it. So using this term, then we get delta t is equal to gamma delta t pi d delta p. Or we can written in this way, delta t is equal to 1 square root of 1 minus v squared divided by c squared delta tp. So that is the relationship we're talking about. Now what does this mean? Means that delta t is measured by the inertial system O is longer than the time interval delta Tp measured by O pi. This is a delta T pi, and here is measured by delta T. Consider the speed of light is constant. So in these cases, if you're measuring this system in the, this location, the time is longer. So that's why